Hello and welcome to our lesson on surface area to volume ratio. So today's lesson is on surface area to volume ratio, so if you can write that in your books. By the end of this lesson you should be able to calculate the surface area of a cube, you should be able to calculate the volume of a cube, and you should be able to calculate the surface area to volume ratio of a cube. So as we would do for any other lesson, the title is surface area to volume ratio. This is obviously a lesson recording, so if at any point I'm moving too fast, you can pause the video, catch your thoughts or rewind it, have a think about what I've said and press play again. Okay? So let's start, as we would do for any other lesson, as we're in the classroom, with a keyword. And the first keyword we're going to talk about is surface area. Okay? Surface area. We can define surface area as the following: the area around the outside of an object. So let me just check that I'm recording. I am. The area around the outside of an object. Okay. Now an example of this would be an area around the outside of a cell. So we can just put underneath here, e.g. area around the outside of a cell. So if you think of the cell membrane or the cell wall, this would be the surface area of the cell. When you're looking at it, the entire outside of the cell. Okay? It's calculated as the sum of the areas of all faces of the shape. So we can put, I'm going to use this blue colour, that it is calculated as the sum of the areas of all faces of the shape. Of all faces of the shape. And an important point we need to make before we have a look at an example of surface area is that surface area always has squared units. So I'm going to change to red because this is an important point. We can say that surface area always has squared units. What we mean by that is if you've got a unit of measurement such as a centimetre or a millimetre, what you need to do is you need to put a little 2 above those units. That shows that it is area. Okay? So let's have a think about a cube, because in GCSE Biology you are frequently asked to calculate the area of a cube. So if I draw us a dodgy cube, because as you know I'm amazing at drawing. So there, look at that. Someone call the graphics design department. That's amazing. So I want you to imagine I've got a cube, and this cube has the following measurements. Along its base and its top, it is 1 millimetre wide. So 1 millimetre wide. Its height is also 1 millimetre because it is a cube, and its depth is also 1 millimetre. So it's 1 millimetre by 1 millimetre by 1 millimetre. Now remember, a cube has 6 faces. So we need to calculate the area of one face and then times that by 6. So we can say area of one face, is equal to the width times the height, okay? Or the bottom bit times the upward bit. So we can say that it is width times height. Now, when I'm saying width and height, my width is this bit along the bottom and my height is this bit going up the side. So the area of one face for this cube would be 1 times 1. 1 millimetre, sorry, we're not measuring in centimetres, are we? 1 millimetre times 1 millimetre gives me 1 millimetre squared, because we're measuring our units as a surface area, so it is a squared unit. And as we said earlier, a cube has 6 faces. So a cube has 6 faces. Therefore, to find the area of the cube, you would need to times this by 6. So you could do 1 millimetre squared times 6, because there's 6 faces, which would give us our answer of 6 millimetres squared. That is our surface area. Okay, so that's our surface area. We've done the width times the height to give us the area of one face. A cube has 6 faces, therefore we've got our surface area of 6 millimetres squared. What I'm going to do is I'm going to draw you a cube like so, and I want you to do that in your notes, please. I'm going to put some units on it. I want you to pause the video and I want you to work out the surface area of this cube before I go through the answers. So our next one would be 3 centimetres by 3 centimetres by 3 centimetres. Pause the video now, see if you can work out the surface area of that cube. Okay, so hopefully you should have paused the video and had a go at working out the surface area. So we can start by working out the area of one face. So we've got our area of one face. To do that, we would need to do 3 times 3. So 3 centimetres times 3 centimetres, which would give us 9 centimetres cubed. Okay, remember a cube has 6 faces, so you would then do 9 centimetres cubed times 6 to give you an answer of 54 centimetres cubed. So squared even, not cubed. 54 centimetres squared. Let's do one more just to make sure that you're happy with it. I'm going to have to spam the mouse button now to get rid of all this, all the way back. Keep on doing, keep on doing. Oh, it won't let me undo anymore. So I'm going to have to switch to the rubber, and it's going to get rid of it as white. It doesn't matter. We're not that bothered. We can just put our units in. So instead of having 3 centimetres cubed, we're now going to have 5 millimetres, 5 millimetres, and 5 millimetres. So just to be clear, it's 5 by 5 by 5 millimetres. Pause the video now, see if you can work out the surface area of this cube. Okay, so you should have had a go at that surface area. Let's write down first of all the area of one face. So our area of one face is equal to 5 times 5, so 5 millimeters, times 5 millimeters is equal to 25 millimeters squared. That is the area of one face. We then need to do 25 millimeters squared times 6 to give us our area of 150 millimeters squared. Okay, so hopefully you got all those right, and hopefully you're happy with calculating surface area now. Essentially, in terms of biology, surface area is about how much space you have to exchange things with your environment. So the bigger surface area an organism has, the more space it has for a diffusion to happen across. So I'm going to just put now in red, a bigger surface area allows more diffusion / osmosis. We haven't spoken about that, but we will next lesson. / active transport to happen. So osmosis and active transport we haven't spoken about. We're going to be doing lessons on those. But for now, you just need to know that a bigger surface area allows for more diffusion, osmosis, or active transport to happen. Right then. Let's refresh our screen because now we need to talk about volume. And volume is a key word. So we can put the keyword volume. Volume can be defined as the amount of space a 3D shape takes up. So the amount of space a 3D shape takes up. Okay, so for example, how much can you fit inside a cell? So we can put here, e.g., how much fits inside a cell? Fits inside a cell. Now, volume always has cubed units and is calculated by volume equals length times width times height. So we can put underneath here is calculated as volume equals length times width times height. Okay, so it's calculated as length times width times height. And we also said, which I'm going to add in red, we said that it always has cubed units. So always has cubed units. And what we mean by that is if you've got millimeters or centimeters, when we put a little 2 there for surface area, volume will have a little 3 above it because it's a cubed unit. So let's see if we can work out the volume of some cubes, okay? So if we've got a cube, and I'm going to go again for my nice easy 1 millimeter even sides. So our width is 1 millimeter our height is 1 millimetre, and our length or our depth is 1 millimetre. We need to do the length times the width times the height. So we're going to do 1 millimetre times 1 millimetre times 1 millimetre, which gives us a volume of 1 millimetre cubed, because we've got 1 times 1 times 1 to give us 1 millimetre cubed. Let's see if you can do one by yourself. So if I've got another cube here, except this time, instead of being 1 millimetre, we're going to use the measurements we used before, and we're going to have 3 centimetres by 3 centimetres by 3 centimetres. Pause the video now, see if you can work out the volume of this cube. Okay, you should have had a go at working out the volume of this cube. So to answer this, you should have done 3 centimetres times 3 centimetres times 3 centimetres. This should have given you an answer of 27 centimetres cubed. So the volume of this cube is 27 centimetres cubed. Let's do one more before we look at surface area to volume ratio, which is a bit more difficult. So our final cube, again, these aren't drawn to scale. I'm just adding numbers to them. Our final cube has the following measurements. It has 5 millimetres along the bottom, 5 millimetres along the side, and 5 millimetres high. Pause the video now, see if you can work out the volume of this cube. Okay, so let's write our answers. So we're working out the volume, we're doing length times width times height. So length times width times height. So 5 millimetres times 5 millimetres times 5 millimetres, we should give you an answer of 125 millimetres cubed, because remember, we work with cubed units when doing volume. So volume is the amount of space a 3D shape takes up. It's, for example, how much fits inside of a cell. It's calculated as volume equals length times width times height, and always has the units that are cubed. Let's move on to our final bit of this lesson then, and start having a look at surface area to volume ratio, and this is a bit more difficult. Okay, we're going to combine the two ideas together now, and this is the bit where it becomes especially important for biology. So surface area to volume ratio. Okay, we can define this as the relationship my phone's just playing music randomly. The relationship of the surface area of an organism to its volume. So we're comparing the surface area of a volume, the surface area of an organism to its volume. Sorry, my phone kind of put me off. Now this is always expressed as a ratio. Okay, so it's always expressed as a ratio. Always expressed as a ratio. To work this out, so to work out surface area to volume ratio, so surface area, I'm putting this in regs, it's important, dot dot to volume ratio is calculated or is equal to the surface area divided by the volume. So surface area divided by the volume. So let's have a look at an example, okay? We're going to use the same sizes we used before. So we're going to start with a cube that is 1 millimetre by 1 millimetre by 1 millimetre, okay? So 1 millimetre by 1 millimetre by 1 millimetre. We've already said earlier that we can work out our surface area. I'm going to use a different colour for each one. Our surface area is equal to 1 times 1 to the power of 6, or 1 times 1 in brackets in times by 6. So 1 times 1 is 1, times 6 is 6. So our surface area for this cube is 6 millimetres squared. Okay. Our volume, on the other hand, our volume, I'm trying to find a colour I can use. So our volume is equal to 1 times 1 times 1. 1 times 1 times 1. That means that our volume is 1 millimetre cubed. Okay, so there is a 3, not a 2. So 1 millimetre cubed. To work out our surface area, we now need to do the surface area, which is 6 millimetres squared, divided by the volume, which is 1 millimetres cubed. What that will give us is an answer of 6 divided by 1. It will give us an answer of 6. What that tells us is that for every 1 volume, we have 6 surface areas. Therefore, you would express that as 6 to 1. So this cube has a surface area to volume ratio of 6 to 1. Let's try another one before I'll give you the last one to do yourself. So no surprises. We're going to use the same cube sizes we've used previously, so you've already got your surface area and your volumes worked out. So we're going to do 3 centimetres by 3 centimetres by 3 centimetres, okay? So our surface area is equal to 3 times 3 in brackets times 6, which gives us our surface area of 54 centimetres squared, okay? Our volume, on the other hand, so our volume is equal to 3 times 3 times 3. So 3 times 3 times 3, which gives us our volume of 27 centimetres cubed. 27 centimetres cubed. If we did 54 divided by 27, so let me just open up my phone so that I've got a calculator. If we do 54 divided by 27, that gives us an answer of 2. What that is saying is for every 1 volume, we've got 2 surface areas. We've got double the surface area. For that reason, we can express this as a surface area to volume ratio of 2 to 1. Okay? So what I want you to do is I want you to try and calculate it, and this one is a bit more difficult, however, it's the only one I've left over for you. I want you to try and calculate the surface area to volume ratio of the cube, using the numbers we used before, of 5 centimetres. Okay, so 5 centimetres by 5 centimetres by 5 centimetres. Pause the video now, see if you can work out the surface area to volume ratio of that cube. Okay, so you should have paused the video at that point, and you should have first of all worked out our surface area. Our surface area would be 5 times 5 to the power of 6, times 6. It's not to the power of, I keep using it because I like to think I'm fancy with maths when I'm not. So 5 times 5 times 6 would give us a surface area of 150 centimetres squared. On the other hand, our volume would be calculated as 5 times 5 times 5, 5 times 5 times 5, which would have given you a value of 125 centimetres cubed. Okay? Now if you do 150 divided by 125, you will get, so 150 divided by 125, you will get a value of 1.2. Before that can be placed into a ratio, you need to make it a whole number. So this must become a whole number. So we can put needs to be a whole number. So to do that, we can times this 1.2 by 5, because we're trying to get rid of this 0.2. That will give it a value of 6. But because we've times the surface area by 5, we need to times the volume by 5. Therefore, our surface area to volume ratio would be 6 to 5. Okay? Because we've times the top part by 5, so we need to times the bottom part by 5. Therefore, we're getting a ratio of 6 to 5. If you can't do that, don't worry. It's not the end of the world. It's just, this would be a higher level answer. So that's surface area to volume ratio. Now, just to finish off this lesson, we need to just quickly talk how this relates to biology. Okay? So, as a rule of thumb, when a cell increases in size, its volume increases faster than its surface area. So we can say, when a cell increases in size, its volume increases faster than its surface area. Now, if you think about it, the reason we know this is because surface area is only squared, whereas volume is cubed each time. So we can say that surface area is squared each time, but we can also say that volume is cubed each time. Okay, so the volume increases much faster than the surface area. When there is more volume than there is surface area, diffusion is longer. So we can put in red when there is more volume than surface area, comma, diffusion is longer. Diffusion is longer slash slower. And just to finish us off, I want to compare this with two cubes. So I'm going to draw one cube first, our favourite cube, the one that is 1 by 1 by 1, and we'll give it the unit centimetres this time, make it a bit bigger than it has been so far. So 1 centimetre by 1 centimetre by 1 centimetre. Okay, if we work out its surface area, so the surface area of this cube is 1 times 1 in brackets times 6, which gives us a surface area of 6 centimetres cubed, squared. Our volume, on the other hand, so our volume is 1 times 1 times 1, which gives us a volume of 1 centimetre cubed. As we said earlier, if we do 6 divided by 1, we get 6. Therefore, the surface area to volume ratio of this cube is 6 to 1. Because this has a much bigger surface area than it does a volume, diffusion would be fast. Okay, so diffusion would be fast. And the reason it would be fast, and the reason we know it would be fast, is because this is bigger than this. So we can say the volume, sorry, the surface area even, not the volume. So the surface area is bigger. So because the surface area is bigger, diffusion would be fast. On the other hand, if we do another cube, and this time it's going to be much bigger, in fact it's going to be 10 times bigger, we're going to have 10 by 10 by 10. 10 centimetres by 10 centimetres by 10 centimetres. This time our surface area will be equal to 10 times 10 times 6. So 10 times 10 times 6, which would give us a surface area of 600 centimetres squared. Okay. On the other hand, our volume would be equal to 10 times 10 times 10, which would give us a volume of 1,000 centimetres cubed. If you do 600 divided by 1,000, so if you do, I need to change my colour, get rid of that blue dot. If we do our surface area to volume, if you did 600 divided by 1,000, you will get 0.6. To turn that into a whole number, you would need to times it by 5, which would give you the value of 3. Because we've times this by 5, we need to times the bottom bit by 5. So that gives us a surface area to volume ratio of 3 to 5. Now, this time, let me just change that 5 because it's the worst 5 I've ever seen. This time, because the volume is much bigger, diffusion would be slower. So the volume, much bigger. Therefore, you can say diffusion would be slow. Right then. You should now be able to calculate the surface area of a cube, you should be able to calculate the volume of a cube, and you should be able to work out the surface area to volume ratio. Till the next lesson, please take care.